that will be coming to one's mind? I think if Rutuja has also joined, okay, Abhishek is only there. So Abhishek, what comes to your mind when someone comes to you that okay, I need to deploy this particular project into the production? What question will you be asking him or her? That okay, I need this, that. Give me just one or two examples.
Sorry, I can't understand.
Okay, I'm saying that let's say you are doing some of the DevOps work. Let's say you are deploying
Yeah,
something on Kubernetes, right? And I come to
yeah.
you and I say that Abhishek, this is one Node.js or React product or whatever it is, application that we need to deploy on Kubernetes. So, what questions will you be asking me?
Actually, I heard yeah, don't have knowledge of that.
Okay, so I'll tell you. Let's say a normal application, let's say Java application is also there. So, what the first question comes to my mind is, as a DevOps person, that I need to know what is the environment that will be there. Let's say the person I'll be talking about the Java application. I think that is the familiar language for you. Any Java application, right?
Yeah, yes, sir.
Okay, perfect. Let's say the application is a legacy application wherein the code is written in Java 8, and now Java versions more and more have come into the picture. But that is a legacy application, so you'll be asking that okay, what JDK version or what Java version it's supporting, because based on that only you will be having your infrastructure ready. Let's say if you deploy, if you have the JDK 12 on your system and the JDK 8 application is coming. So in that case, there can be some breakage, right? So there has to be an communication, and whenever you communicate, the dev and ops, whenever they communicate, they collaborate on the things. And what do we mean by integration is that let's say he comes up that okay, you already deployed it on Java 8. Let's now deploy it on a further version because I have made the changes in the application. So I want to deploy it on, let's say, the Java 10. So you will be making the changes in the environment, and then on the top of your application, now you need not deploy the whole application. You might be deploying only the features, the new features which have come up. So that is the integration. So you have to integrate any kind of a new feature that is coming into the picture. Is it clear? Abhishek,
Yeah, yes.
okay, perfect. uh, Now whenever we are talking that okay, this integration and all, whatever the things, the communication, collaboration, whatever is happening. So what all at the background is there? So those are the superficial terms at a high level. Now these are the terms which are working at the project level, that a particular developer is building a code, and then the code is being built. Now this build is being done by these developers on their local machine directly, or we can actually come up to the DevOps as well. How will be coming up? That I'll come tell you. So there is a build which is happening. Then there is a handoff to the test team that okay, this will be deployed in the test environment. Then again a handoff for the release, and again a handoff for any kind of changes to be made in the further process. So one release is there, but the product life cycle doesn't end over there. We need to move further as well. For example, I'll talk about application Paytm or let's say Netflix. So they are continuously releasing their new versions, or let's say Geo application, which is Geo Cinema. So they are continuously building up on that. So it again comes to the operations team that okay, you have to check whether anything is not breaking in the release which we have already done, and based on the feedback, we'll be again making the changes in the code. But over here, what we are seeing is there are the some kind of a manual handoffs or something that are happening. After that only it is going to various processes. So we say that okay, it was working fine in the dev environment, it is breaking, it is going firefights in your environment. So ops is the problem now. Everything worked fine in my environment. So DevOps comes to the people for resolving these kind of issues only. As we said, works on my machine, not on your machine, not my problem. So if you see, this is a classic example. Whenever we talk about any kind of a team or anything, there is an I which is hidden in a team. So how DevOps work is DevOps is not working for individual people. DevOps work for the whole team, and the team as a whole deploys the application to various environments in a continuous manner. So, as I said, this kind of a wall, which is a confusion between the DevOps and the Ops, that is removed by DevOps. And what it happens is because this wall is removed, the time for the release is shortened, and the time for the product to be given to the market is also shortened. By that, we are actually getting more revenue, and then based on the feedback, we are again working ahead on our idea, and this cycle continuously repeats. So till now it is clear, Abhishek? Hello, Abhishek?
Yes, sir. It's clear now.
Okay. So now coming to how DevOps actually works is, so you might have already been seen that there are various kind of scrums which are happening in various companies. Scrum is a new methodology. Earlier we were having the waterfall model, but now Scrum has come into the picture, wherein the people are given a timeline to work on something. Small features are delivered at the end of the Scrum, and then this is how the whole plan works. So in that, what we have is that a new item is added, then there are reviews which are happening, there are multiple iterations which are happening, and then the particular product or the feature is released to the market. But in the case of DevOps, if we are having any feature which is released after 14 days, there will be a loss. Why loss? Because there are some of the features or some of the additions which we need to do on our current application, which have to be done not after the end of the Scrum, but in a manner wherein sometimes you will be releasing three features per day, sometimes you are releasing only a single feature if it is a big feature which is being released per day. So that is how it works. We plan for whatever the anything, any item which we need to have, we keep it in the backlog. Then an item is taken, on that daily reviews happen, and then it is released, or rather I'll say delivered. Once it is delivered, we get the feedback from the market, or we get the feedback from some of our team members as well, who are actually doing kind of a testing on the live products as well. And then we actually add on to our cycle for any kind of new changes which we need to do, and then we move ahead for the further development and further release. This is a classic example of how a DevOps cycle actually works. There is a code which is written, then it is built, and as I said, there is a testing team which actually tests the code, then they release it to the various environment. Then the operations again see based on the feedback that what extra is to be added. They tell the team that okay, this is the particular thing which is needed. Then the developers again do the coding, again it is built, test, then release, and then if a new feature is required, then the feedback is given. Or if there is no new additions to be done, but on the top, after the operations team has checked, then also there are some of the new features which the build team will need to do. So again, the developers will be giving the code for the building, then testing, and this is how the whole cycle works. Now, why all this particular thing matters? Why is it required? Means what is actually the need of DevOps? So basically, the thing is that in any kind of a development wherein we are following the agile methodology, which is very common nowadays, there are, as I said, features to be released in a very fast manner, in a rapid manner. And for that, if we are doing only the continuous integration or only the normal development or only the continuous delivery is being taken into the picture, then there is, you can say, not much of the thing that will be coming to know about whether the particular product is working fine, or whether any new changes are needed over there, or any breakage has happened. So for that particular case only, the DevOps team comes into the picture, because what they do, they actually combine all these things together, and they also give the feedback to the dev team regarding any kind of a thing which is not working, and then based on that only, the whole product cycle becomes smoother. How it happens is because we are having multiple environments which are actually same. One of the images which I shared with you, that it is working fine in the dev environment, it is not working in the other environment, it's an ops issue. So DevOps actually makes the use of some kind of automation scripts or some kind of automation tools by which the configuration is also the same. And if any kind of a new machine on a new server is to be deployed for any of the environments, because of automation, even a single thing on those particular servers or in those particular environments is not degrading, or is not kind of you can say diverging from what is there in the previous environment. So that is how the DevOps is actually helping the whole cycle. Now we have been talking about that, okay, DevOps, but what actually DevOps is? What is there in the depth for DevOps that we are going to discuss now? So these are the DevOps principles wherein we follow one particular culture. And as I said previously, we try to automate each and everything till the extent it is possible. We measure the results, whatever are there. Then, whatever feedback we get, we share the feedback to the teams again. And then this whole camp cycle again works. So, these are the four DevOps principles. Culture means the people, the process, and the tools which we are using. Automation, there is infrastructure as code. And before moving ahead, I want to like to ask Abhishek. Abhishek, is there any kind of a infrastructure as code tool that you know about?
No, no,
Sorry, come again.
I don't. I don't know.
Okay, okay. So I'll tell you what infrastructure as code is. Basically, Ansible and all, which are doing the configuration management, can also be used for automating your infra as well. Specifically, if we are talking about the cloud infra or your public cloud, private cloud, any kind of a thing, the on-premise data center, anything which we have. So that kind of a thing can be done not only through Ansible, but there is one cloud agnostic tool, which is Terraform, which can be used for the same. So what it does is it not only helps for us to have the whole configuration on the infrastructure to be done in an automatic manner, but it also helps us to seamlessly spin up the whole infrastructure in a very rapid manner. We just need to do some kind of basic coding over there. And then based on that, whenever any kind of a new server is to be spun up, that can be easily done using our old code which we have already written. Now measurement measures everything. So as you are working on monitoring, so monitoring is one of the aspect wherein you measure how the network is behaving whenever some new hits are coming to the application, how my application itself is behaving in terms of the resources, be it the CPU, be it the memory. Are there any more resources required? Have we under provision our infrastructure or have we over provisioned our infrastructure? So it measures everything. And then based on that, we actually share whatever the feedback that we get. Let's say that we require only 2 GB of RAM to be used, and in the peak hours, the RAM requirement increases to 8 GB only, but we have provisioned our machine of 32 GB. So the server that we are using, it's of 32 GB. So it is of no use, even if we are using a single server as well. Instead of that, what we can do is we can actually use maybe 16 GB because 50% memory requirement, and taking into the consideration any future increase in the traffic, we can use 16 GB. And in case we have under provision as well, then also it will give us the feedback. And based on all this particular sharing, again, it will be given to the people, and the people will be making changes regarding whatever they have written on the tools and all. And again, this whole cycle works. So these are the DevOps principles, which again work in a cycle. And these are the practices. So what are the 8 DevOps practices that we have is, first of all, that we need to have any kind of transparency, that whatever has been built up, it should be known to each and everyone who is a part of the whole team. So that is a transparency. By having the transparency, we eliminate any kind of an overhead which comes up. So no one will be coming back to us asking that okay, what has been delivered, what are the resource requirements that we have put in over there, what are the challenges that have been faced and all things, because we have automatically done each and everything, and based on that we already have the things in files wherein the automation code is there. Then whatever the automation testing is being done, we actually use the APIs for the same. And how the APIs, as you told that you are using Splunk, so on the Splunk we actually need to expose one of the APIs for our system, and then using that particular API it is actually monitoring the whole system. Whatever the product that we are delivering to the market, it is minimum viable product. In DevOps we need to have a dedicated team in the terms of DevOps, dedicated team in the terms of developers and everything. And since we are having a dedicated team for DevOps, so it is responsible for making sure that the infrastructure or the servers, they are up and running 24/7, and hence the business is not impacted because of that. The loosely coupled architecture, as you already told that you are working on Kubernetes as well, means you have done some kind of a hands-on, and Kubernetes follows that methodology, or wherein we need to have each and every service decoupled from each other, and that is known as the microservice architecture. Means we are not having any kind of a monolithic application or something wherein each and every thing was a part of a single application. We are actually dividing the whole application into smaller chunks, so that if any one chunk is impacted, it has not impacted the whole application. So that is how DevOps works. We are having the microservices, and hence you get the loosely coupled architecture. We are minimizing the hands-offs and maximizing the flow. How? Because we are actually following, I showed you that particular cycle, right? So this one. So the hands-offs are not there because we are automating each and everything. And based on this particular thing only, the hands-off are removed, and we are actually growing towards the automation part wherein we need not restrict the flow. Then our whole application is being delivered in small batches, or I'll say small chunks. And whenever the application is being delivered in small chunks, it is again helping us to give the feedback earlier. So it may be that our release is, let's say today is Saturday, and maybe the release is on Thursday. So we need not wait till Thursday that, okay, this particular thing is breaking. No. In DevOps, we actually do the work each and every day. We do the build, we do the deployment on the test environment or the other underlying environments or the smaller environments. And based on the feedback, we continuously work on that so that the final product, which we are going to release on Thursday, it will be up and running, having all the things required. So clear till now?
Yeah.
Perfect. Now, again, I think you might already be familiar with this particular image wherein the people are blindfolded and they are being asked that, okay, what are you actually looking at? So till now, I have told you this whole elephant only. And everyone is saying, if I want to ask them that, okay, what are the various things about DevOps that you know? So they'll be saying that, okay, now this whole elephant, till now, what I come to know is DevOps, and DevOps. But what actually are the things which actually make this whole DevOps? So as we saw in the first slide itself, the people are collaborating. So development and the operation teams collaborate with each other, and that falls under DevOps. We automate the things for doing various tasks, for releasing our product to the final server, and for building that server as well. We need to have the methodology so that the servers also spun up in a rapid manner, taking very less amount of time. So again, DevOps is using automation. And as I said, when the delivery is on Thursday, we will be doing the small deployments to the smaller environments. So that is how the small deployments are done. Then DevOps is we need to have the switches between the features that okay, this is a feature which we need to develop again, work on it, work on this feature, work on this feature, and then we actually do the collaboration of all those features, we integrate all those things and then make our final product. That is DevOps. And as I told you, infrastructure as code using Terraform or using any kind of other infrastructure as code tool, it also falls under the DevOps. And now, what is Kanban? Do you know Kanban, Abhishek? Okay, so I'll tell you what Kanban actually is. So in Kanban, till now we were talking about that, okay, agile we need to follow, we'll be having some scrums and all those things. Now, Kanban is that method, or you can say practice, wherein whatever the small chunks of our application are there, means whatever the small features that we are developing. So we need to have those particular features to be deployed, not waiting for the Scrum cycle to get over, but we need to pick up one feature, work on it, and then release it. And these features are critical for the business. So these business critical things or business critical tasks or business critical features that we need to release in a rapid manner, those have not to follow the Scrum, they follow the Kanban methodology. And by Kanban, we mean as it comes, pick it up and deploy so that more and more business can be catered and more revenue can be generated. So that is how the Kanban works. Kind of an agile methodology itself, but different from Scrum. Now, till the time we were discussing about the build and all those things, I think this continuous integration would have also come up into your mind. So you have idea about continuous integration. What do you exactly mean by continuous integration? Abhishek?
Like we build the code and test it, and then again it build it and first, then test it. It's a continuous integration.
Perfect. So as you said, in continuous integration, we are actually building the code. Then again, it is being tested on the CI server. We are building it. Then we are deploying actually it into the some other environment. Then again, based on the feedback or the result, again a feature is being developed. Some changes are done. Then from the source code repository, again we are building it. So the process wherein a code is checked in to the source code repository, then the code is built and not deployed anywhere, but till that particular phase wherein the code is being built and we get some kind of an artifact or some kind of an output for that particular product. So that is known as continuous integration. And whatever the output that we are getting, we are deploying it somewhere. Then again, checks are done on the same by the testing team. Again, the feedback is given and again the cycle is repeated. That is known as the continuous integration cycle. Now, these are the things that we actually do in the case of the continuous integration. So we are having any kind of a source code, like in the previous slide, we are having it on the system. Then the source code repository in the previous slide, it is actually the version control system. You might be knowing about GitHub or TFS or maybe GitLab or Bitbucket, any kind of a version control system. And in the version control system, we are actually keeping our code on a source code repository. So Git is one of the version control system which is very popular nowadays. Let's say that we have our code on GitHub. Then that particular source code is pulled from the source code repository and it is built. Then static code analysis takes place on the same. And by static code analysis, what we mean is, as the word suggests, code analysis. So whatever the code that we are having, we need to work on it regarding any kind of vulnerabilities with respect to the code, not with respect to the application, but with respect to the code. Let's say if the code has been written in a perfect manner, are there any non-use variables on the code, or are there any kind of functions which have not even been used but just written? Maybe sometimes, as you know, the developers work, so they find that okay, this particular method or function is not the one which is giving me the correct output, so I'll be just keeping it over there, I'll not be using it. So that also comes under the non-best practices. That is also not a good practice, to keep any function as it is without using it. Then unit tests are run. Now what unit tests help us is, they actually help us in making sure if the whole code has been utilized correctly, and whatever the lines in the code are, those have been covered. Each and every line should be covered so that we can get rid of any kind of redundant code or redundant variable or whatever it is. So we actually write some unit test cases, we work on those unit test cases, and those are again automated because this is a DevOps cycle. Then the code coverage we get based on those particular unit test cases only. We run the code coverage analysis. And then, as I said, we get the build artifact. Let's say if we are having the Java application, we'll be getting the .jar or .var, whatever it is there. If it is a .NET application, we'll be getting .exe or .dll. In the case of the JS applications, let's say we are having the React or Node or whatever it is, we'll be getting the respective output. Then we set up the test fixtures. Now, what the test fixture I mean is, we are running some kind of a, let's say, integration test. So those particular fixtures are to be set up. Then we deploy it to the test environment. That okay, in the test environment, I'll be actually working on testing the whole application for the integration test, for the functional test, or whatever it is. And again, since we are talking about the seamless delivery in a very short time span to the production environment, hence we need to automate that as well. So once all those particular tests and all are run on the test environment, we again publish the reports of those tests, and then based on reports only, we actually give the feedback to the development team. Then the development team says that okay, these particular things were to be there for this particular feature. Let's say we need to change the look and feel of our inbox of any kind of an application, wherein we are trying to move this number 20, which we are seeing, the slide number at the bottom, we want to move it over here. And we also need to move this 3RI technologies to the left. So let's say in the feature which were the developers developed, they moved this 3RI technologies over here, but they forgot to move number 20 to the right top. They moved it again to the left top. So they will be given the feedback that okay, everything is working fine, but the position of number 20 should not be on the right. It should not be on the left. It should be on the right. So based on those particular reports and all, the development team will be given the feedback. Then they will be making change again in the source code, and based on that, again this whole cycle gets repeated. So this is how the continuous integration cycle works. So this is a whole comprehensive diagram which actually makes you understand what actually continuous integration is. So Abhishek, are you clear about this one?
Yes.
So if anyone asks you that, okay, how the continuous integration works, what is the static code analysis and all, you will be able to give a brief about that, right?
Yeah. Yes.
Perfect. Okay, now. So now you might be seeing these tools on the screen, right? How many tools you are familiar with? You know any of these tools?
Jenkins only.
Jenkins and
Jenkins only. And Visual Studio.
Jenkins and Visual Studio. Perfect. So Visual Studio is the IDE wherein we are actually working, right? And we are doing multiple things regarding the code development, and through the Visual Studio itself, we can actually do the build of the whole code. We can actually release it to one of the servers which we have configured. We can release it to the IIS, which is actually the web server in the case of the Windows systems. Jenkins, freeware, open source tool, which is again doing these things. Over over here, we are actually doing the things directly from the server on Jenkins. We need to do some of the configurations, be it related to plugins or whatever it is. TeamCity also works in a similar manner. Travis CI again for the same. Circle CI, Hudson, you can say kind of father or brother or whatever of Jenkins by the same company. Bamboo again, one of the CI/CD tools which is used. So if we talk about all these particular tools, so if we talk about all these particular tools, these are actually working in a similar manner. And by this, we come to know that CI is about what people do. It's not about what tools they use. So Jenkins, Bamboo, or any tool you might use. Some of the tools which are not mentioned, maybe you are directly using the GitHub Actions, you are using the GitLab CI. Doesn't matter. Till the time you know what you actually need to do, there will only be some kind of a syntactical changes or some other terminologies will be used which will be different in Jenkins YAML pipeline, which will be different in the CI/CD pipeline on Visual Studio, or which will be different in the CI/CD pipeline on GitLab CI or GitHub Actions. But you are again doing the process. You are going through this particular process only. So CI is about this only. It is not related to anything else. CI is just a practice wherein you need to integrate frequently. You are making some of the small changes so that whatever the final product that you get, it is not having any kind of an issues or something, and it will be perfect available to be released on the perfect date, and wherein you actually get the fast feedback. So remember those days. I think you might not have seen, but I think we have already been part, maybe me, Rupali, we have already been part of that particular cycle wherein we used to have the reels inside our cameras. We never used
Yes,
to have the digi cams. So at that
right.
time, we used to get the feedback only once our photograph has come up. That okay, I was actually looking like this. My eyes got closed, and you didn't tell me at that time. Nowadays, we can directly say that okay, my eyes are closed. Please click another picture. So we get that particular fast feedback in the case of the automation world. Now comes the CD part. So Abhishek, what is one thing that you are seeing new over here? Rather, I'll say two things which you are seeing new over here. You can unmute yourself, Abhishek.
The release part only. Re- Deploy and release.
Deploy and release. Perfect. So now, in the terms of CD, the full form continuous delivery and continuous deployment. So there are two things. There are two aspects which will be coming against just after a while. So what is CD? It's basically deploying the application to any kind of a new environment. And once this application is tested on whatever the environments that we have, the underlying environments, then we need to release it to the production. And then there might be some of the hot fixes or anything based on which we'll be again building the application, again having those particular deployments, again testing it on the test environment, and again having those release cycles coming into the picture. So as I said, there are two things: continuous delivery and continuous deployment. So Abhishek, based on these particular diagrams, can you explain me what is the difference between the two, continuous delivery versus continuous deployment? If I want to ask you, then what will you say? What is the one aspect wherein these both differ?
In continuous delivery, deliver the application manually, and in continuous deployment, we automate that one.
Perfect. So delivery, if I talking about in the layman terms, I just need to deliver it. Okay, I'll be just delivering it. Let's say a delivery boy comes to your house, and then you will be taking, let's say there is a television. So he is delivering you that particular television which you ordered online, and he just gives it to you and goes away. Then when you are calling someone and having those particular things deployed on the system, so that is a deployment. Let's say that there comes a system wherein that delivery boy comes in, deploys that app, means he sets up the television on one of your walls and then goes after checking that okay all the channels and all are working. That is the kind of a system which comes under the continuous deployment. So this is a difference. Delivery, he goes, just directly delivered. Deployment, you need to have it automated. That's it. These other things means the code is done, unit test, integrate, acceptance test and all. These are the part of continuous integration. Nowadays, there is again one other term which has kind, which is the continuous testing, wherein this the testing, the acceptance test and the integration test and all those come under the continuous test. But that is being used by only some of the tools and all. That is not a global accepted term, I'll say. Some of them use it, some of them consider it as a part of the continuous integration only. And then the continuous delivery means whenever you are manually deploying it to the production environment, you are delivering it on the environment, and continuous deployment when that is automated. So these are the things. Now again in continuous delivery as well, we are having the feedbacks from the results given to the development team. As we saw in one of the previous slides that we were having some kind of reports and all generated. So those again give the feedback from the staging environment as well. We can generate the reports, and from the production environment as well. That okay, this is looking good, but what if we add this new feature as well? Again coming over here, feedback given continuously. So that is how the continuous delivery is happening. And as the continuous delivery is there, the deployment to production is manual. Abhishek, what do you suggest? Should we go for the continuous delivery or should we go for the continuous deployment in any of the cases? Which one will be better?
The continuous deployment is better.
Why? Why continuous deployment is better?
Which automate everything.
Okay, but let me tell you the other aspect. Rupali, if I may ask this question to you as well, that what do you suggest? Continuous delivery or continuous deployment? Which is better?
Yeah, continuous, both we need it. Continuous delivery and either or you're asking.
Correct. So Abhishek, it depends on what kind of a system you are working on. Let's say that you have already developed one particular cycle wherein none of the changes in the code is breaking the underlying environments. Then in that particular case, you can go for the continuous deployment. But when your application is in a new stage wherein more and more features are being added daily and you are doing the things, in that particular case, you need to go for continuous delivery. Why? Because your application is just in the initial stage. You are releasing or your product is in an initial stage wherein based on the market reviews, you are actually adding more and more features to the system, right? So in that case, you need to go with the continuous delivery. In other cases wherein your application is already working very well, only some of the changes are done and which are actually you have already tested that okay these are not breaking in the underlying environments. So in that case, you can actually move ahead with the continuous deployment. Clear?
Yeah, yeah.
Yes.
Okay, perfect. Now the word of caution over here. Why the word of caution? Because whatever the feedbacks and all are being given, you need to make sure that those may be for some of the hot fixes as well, and those can be related to some of the things which were working earlier but now breaking in those environments. So why caution comes into here is because you need to make sure that let's say a new version of the application is being provided to you and you have gathered all the requirements. Now, the first example which I gave, the Java application. So you actually made sure that whatever the system was there for the build, it is having all those things on it. But let's say whatever the production, staging or test servers are there, they're not having all these particular features which you have already have on your dev environment, or you can say the build environment. So you need to first of all have the infrastructure also ready with respect to that, and only after that you will be moving ahead with the delivery to those particular environments. So continuous delivery is delivering the product, but after making sure that the infrastructure is also in line with the main build or dev environment. So that is a word of caution. That is most important, which usually people sometimes forget. Now, what is the DevOps culture? As we already discussed, it is made up of three things: people, process, and products. People means the dev and ops. Process means automating each and everything regarding the infrastructure spin up, automating each and everything regarding the configuration to be done on the infrastructure so that each and every environment is in line, and automating each and everything related to the project delivery as well. We need to have the CI pipeline into the place. We need to have the CD pipeline into the place, and then the products which we are using for the same. Let's say Jenkins is the one which we are using for the CI/CD part. Then we are having the deployment on the, let's say, EC2 instances on AWS. So we need to have those particular EC2 instances also to be spun up. So we need to know that okay, we are using the AWS. We are using one of the compute service of the AWS. So we need to have that particular Elastic Cloud Compute to be utilized. So for that, we need to have the AWS environment to be up and running. Means by what I mean by AWS environment to be up and running is that those EC2 instances should be ready to accept the whole load which we need to have. Then we need to have the other things as well coming to the picture. Let's say the Jenkins is the one which we are using for the CI/CD. Then we are using, let's say, the GitHub. GitHub is also one of the product that we are using. So the whole of these things, the people, process, and the products, they all make the DevOps culture. Now, whenever we are actually working for a DevOps culture, we need to actually move out of our boundaries wherein we actually try to hide some of the things or we don't accept the change or anything. We need to understand that whatever we are doing, it should be communicated well. And whenever it is communicated, if it is in line with the product, whatever the things we need to change, then we need to make sure that okay, that particular change is good. The tools that we are using for having our infrastructure to be ready, our CI/CD pipeline to be ready. So those tools also need to be updated each and every time. There should be a transparency between the various teams. The test team should know that okay, this is the particular date on which they will be given the product and it will be released. So they should be intimated. Then whatever the good behaviors or the good practices are there, we need to boost up the morale of the whole team. So rewarding all those particular good behaviors, we need to keep that in mind. And whenever we are actually working on the DevOps, we need to make sure that the grassroots or the basics are innovative enough. So when I talk about innovation, then whenever we are doing any kind of a change on, let's say, an EC2 instance, instead of doing it through the AWS console, we should have those automated through Terraform. So that is an innovation part. Any person who is working in a DevOps team is accountable for each and everything. And since the teams are collaborating with each other, there should be no blame that I did it correctly and he didn't, or it was working fine on this environment, it is not working fine on that environment. Whenever there are failures, instead of going down because of the failures, we should embrace the failures, because whenever we are failing early, our final product will be more and more robust. There should be a trust between the teams about the things that are going to work. And as I said, there should be collaboration. And when all these are there, there will be already honesty and openness for working in such kind of a team and working on such kind of tools. Now, goals of any kind of a DevOps team is that we need to have the continuous business planning, we need to have a collaborative development, there should be continuous testing, there should be continuous release and deployment, there should be continuous monitoring, and based on this monitoring, we'll be given the continuous feedback from the customer as well, because the customers will also be coming to us and saying that, okay, this is the thing, but what if we add this new feature as well? And based on that, we'll be optimizing the things. So we are actually not only building the ecosystem and practices, but we are building the standards as well. That is how we get the continuous feedback. Now, whenever any kind of a DevOps team is working, what all do we need to know is also important. So let's say a particular team is built up for doing some of the operations related with respect to deploying a web application on AWS. So what we need to do is we need to have that operational knowledge on the top of it. Our system should be reliable. It should be well performing. So when we talk about reliable and performance and security, how do we come to know that, okay, they are perfect? We'll be testing them. So the testing is also important. They will be putting up the load testing on the top of it. By reliability, we need to make sure that whenever a new feature is coming and a lot of load is coming, the system should not break. It should have a good performance, and it should not be vulnerable to any kind of security leaks. So it should be secure enough. Then feedback loops from the production, how we actually build that. We actually build the KPI dashboards, and we actually build the whole monitoring dashboards as well. And whenever the customer says that, okay, this much amount of load came and your application was not performing for these many seconds, because sometimes even seconds of business is important. If you take an example of the big billion day sale of the Amazon, so at that time, if the application goes down for even 30 seconds, that is a huge business loss for AWS. So we need to do the postmortems, that, okay, why the application went down, what was not working, so that we get the feedback from this particular time, because we need not repeat these particular things in the future. And as I said in the previous slides as well, we need to be responsible enough to make sure that, okay, this is my application and it should be up and running, it should not be having any kind of a business loss. So whether our code is passing the test, it's getting deployed, it stays up for the users. So this whole is the responsibility of the whole team, because as we said that we have the collaboration between the teams. And by whole this picture, as we said that when we are actually adding ops into the dev, we are actually making sure that the deployment is working better with the ops. We are using the tools and all to not only monitor, but to make our deployments faster. And we are using the tools to create the production like environments, so that whenever we are actually going to deploy the application to the final production environment, or we are going to release the product, it should not be having any kind of issues. So we need to make sure that whatever the staging environment or pre-prod environment that we are creating, it should be production like. So Abhishek, any questions on this particular slide?
As this is a very basic, this is a very basic introduction session, Arpit.
Mm-hmm.
We can go on to the details when Abhishek joins the actual batch,
Okay.
and he will come up with the queries definitely.
Sure, sure.
I think we can cover up the main the top the tools that we're going to cover in the sessions, right, Abhishek?
Yeah, yeah.
Okay, so for going to the tools, I'll directly move up to this particular tool chain that we are having. So what kind of DevOps tool chain that we are going to have? So this particular pipeline you have already seen into the previous slides as well. So the code, how we are actually going to develop the code, the continuous integration code and all those things, those particular tools come up in this one. Whenever we are talking about the continuous integration, the build, test and all those things come at that particular thing. So the CI tool, which is mostly the Jenkins, the freeware, which we are going to use in our trainings, that is the one. And static code analysis using the Sonar Cube is the one which we actually will be targeting. That is the one. For packaging the whole system means, let's say the jar and all whatever we have developed, we are actually going to deploy it to the artifact repository, and that artifact repository can be artifactory on Access or whatever there is requirement. Then for the release and change management and all those things, again, we are having the same CI/CD tool. Then the configuration or the whole system is spun up, we'll be using the Terraform for the infrastructure as code. And for the configuration, we can move ahead with the Ansible, which is the most popular one these days because it doesn't require any kind of agent or something. Then for monitoring, we'll be having any kind of a monitoring tool that we use to that we want to use, be it Prometheus, be it Grafana, anything. So this is a whole tool chain that we are having. So Git, pre-force and all those things. This is SVN. So Git is the most popular one. We'll be using it. So our source code will be based on the Git. Then whatever the deployment and all those things and working on the build and all, we'll be using Jenkins. Then for monitoring, as I told you, that we are having multiple things. PagerDuty, it actually gives us the outcome that, okay, it gives us the final output, whether our application is working fine or not. Some of the tools not you mentioned over here, Prometheus and Grafana are the ones. Configuration management, Ansible, Chef, Puppet, there are multiple. For the containerized deployments, we are having the Docker for having the containers to be built up, and the Kubernetes to have the whole management of these containers and all. So that is for the configuration management. Ansible, the most popular one. For logging, we can use multiple one, means ELK, which is Elasticsearch Log slash Kibana. We can have the, like we are having the paper trail, we are also having Promptail as well. So those are some of the logging tools. For security, there are Threat Stack, Tripwire, CloudMap, multiple tools which can be used for the same. And for the collaboration between the teams, Slack is the most popular one. Visual Studio was used earlier when people are actually working directly, but nowadays it's another version which works on the various other environments, which is Visual Studio Code, is working fine, perfect. Slack is the most common one because it gives us the liberty to have the configuration, or you can say the collaboration between the teams, not only between the teams but for the applications as well. So for example, if you have any kind of a deployment which is failing, you can actually get the notification on Slack based on the APIs that we have exposed and all those.
Okay. Yes.
So,
So, Arpit, yes, we can stop now.
mhm.
Abhishek, is this done with you? Like you have satisfied with this? Hello, Abhishek, are you there?
Abhishek has yeah, he's here.
Okay, okay. Yes, he's there.
Abhishek, you are on mute.
Yes. So, Arpit, it was wonderful demo from your side, and hope Abhishek uh, liked this one. Okay,
Thank you.
okay, no problem. If Abhishek is not responding, hello, Abhishek, are you there?
Apit, we will get the feedback